This is a lecture about chemical bonding and about the naming of, which is called nomenclature, of the compounds that are formed by the different types of chemical bonds. First thing you should understand is what is a chemical bond. And a chemical bond is simply two atoms that are so strongly attracted to each other that we think of them as joined together. And the type of attraction in a chemical bond is an electrostatic attraction. And specifically, it's an attraction between the electrons of one atom. So I'm just going to draw an imaginary ring. Of course, inside we have a nucleus, which has a positive charge from the protons. And so when you have two atoms that for various reasons are attracted to one another strongly enough, they will become bonded. And so the electrostatic attraction, again, is between the electrons of one atom and the protons of another. Okay, opposites attract. And when they're attractive enough, the two atoms will get as close together as they can, and we call that a chemical bond. Chemical bonds are usually classified as either ionic bonds or covalent bonds. That is overly simplistic. Because it's more like a continuum where you have covalent bonding characteristics on one end of the continuum, and then you have ionic bonding characteristics on the other end of the continuum, and each compound lies somewhere along this continuum, and where chemists decide to divide it between covalent and ionic is somewhat arbitrary. So you'll actually have some books and chemists saying, oh, that's a covalent compound, and others might be saying, no, it's ionic. So some of them are a little iffy, but for our purposes, we'll try to separate them into these two categories too. All right, so what is the difference between a covalent and an ionic bond? In a covalent bond, the electrons that we think of as forming a bond are shared equally. Okay, just a little picture here. So both atoms involved in the bond want the electrons an equal amount, and so they share equally. We have a branch of a covalent bond called a polar covalent bond, and that's for bonds that are close to being ionic, but they aren't quite ionic. And so the electrons are shared mostly equally, we'll say. So the electrons are a little bit closer, spend a little bit more time to the atom that wants them more, and so it's close to equal but not quite. And finally then we have ionic bonding. In an ionic bond, one of the atoms involved wants the electrons, has a much stronger desire, attraction for electrons than the other, and so you can almost think of that atom as stealing the electron from the other atom. So I'm going to write for ionic, the electrons are shared unequally. A lot of people will say they're actually not even shared in an ionic bond, they're donated. Alright, so what determines what type of bond you will have? It is a property called the electronegativity, and very simply put, the electronegativity is the attraction an atom has for extra electrons. Attraction for extra electrons, okay? And there are a couple of factors that determine the electronegativity, and we can talk about that later. But the greater the electronegativity difference is between two atoms that are trying to bond, the more polar the bond will be, and therefore the more ionic character it has. So looking down at the bottom of the page here, if I'm going to call E end is going to be electronegativity, okay, En. If the electronegativity of atom A is about equal to the electronegativity of atom B, we'll have a covalent bond. Okay, they both have about the same attraction for electrons, and so they'll share equally. We have the polar covalent around here, okay, and the electronegativity of one atom will be A little bit more than the electronegativity of another one, but not tremendously more. And finally, if we have what we call pure ionic bonding, the electronegativity of one of the atoms, whoopsie daisy, will be a lot larger than the electronegativity of the second atom. And so the bottom line is one of the atoms will want those electrons involved in the chemical bond much greater, much more than the other atom. And so in a lot of cases, the atom with a higher electronegativity will essentially take or steal the electron from the atom with a lower electronegativity. All right, so as a summary then, ionic bonds, which have a large difference in electronegativity, occur between metals and nonmetals, and they involve the transfer of electrons from one atom to another. There's really not much sharing going on in an ionic bond. All right? Why do they occur between metals and nonmetals? Well, you may or may not be aware that metals tend to give up their valence electrons, that means the electrons in the highest energy level, pretty easily. Okay? And nonmetals have a high electronegativity, which means not only do they not want to give up the electrons they have, they would like additional electrons. So it's kind of a match made in heaven. Metals give them up and nonmetals accept them. So any atom that gives up an electron and gives away an electron takes on a positive charge and becomes a cation. Any atom that accepts an extra electron takes on a negative charge and becomes an anion. And then when you have a cation and an anion, obviously there's a very strong electrostatic attraction between the opposite charges. And so you end up getting a 3D kind of conglomerate of cations and anions that are all attracted to each other, and that's what an ionic compound is. And this type of 3D network is what give ionic compounds the properties they have. Think of table salt, for example. They're hard, as you would expect them to be, because the ions are very tightly packed. They make crystalline solid structures. Again, you would expect that because the ions are tightly packed. And so just to kind of look at an overview of what happened, here's sodium, the making of table salt. Sodium is a metal. Chlorine is a nonmetal. Sodium gives up its one valence electron to chlorine, and so sodium becomes the cation, the little blue balls here, and chlorine becomes the anion. On the other hand, covalent bonds, okay, involve the sharing of electrons rather than a transfer, and so they have to be between two metals that have similar electronegativities or similar attraction for extra electrons. Okay, and so covalent bonds occur between two nonmetals. Remember where the nonmetals are located on the periodic table? They're on the right side of, that was kind of a bad abbreviation, wasn't it, of the periodic table. There, I'll just, okay. That's where the nonmetals are. So if you get two of those combining, they have comparable electronegativities. Neither one of them is willing to totally give up a valence electron, so they will share their valence electrons between them, and that is a covalent bond. Now, this is some terminology that you need to memorize. It's one of those things that might be a trivial multiple choice on your test. When you have a covalent bond, and you have two nonmetals, we call that a molecule. Okay? You'll learn in a later slide that when you have an ionically bonded compound, it is not called a molecule, believe it or not. It is called a formula unit, and I'll go over that in another slide, but I just want you to look at both of them here. So just kind of remember that. You can call both of them compounds, but one is a molecular compound and one is a formula unit compound.